Okay, ladies and gentlemen, today we're going to talk about another parent function family, and the first thing we actually need to do is change this where it says quadratic to cubic. This family is x to the third, so that's how we know it's cubic because it'll have a degree of 3. This point, unlike a parabola, doesn't have a vertex, so the first point we're going to graph I just call the first point. The first point for the original cubic function is 0, 0. So the first point that you would place on your graph is going to be 0, 0. Then from that first point, kind of like a parabola, you graph some next points. So we go over 1 and then we go up 1 to the third because it's cubic. So 1 to the third is 1. So we'll go over 1 and up 3. Then we go right 2 and up 2 to the third. So we'd go over 1 and up 8. And right 3 and up 3 to the third. So over 3 and up 27. That one won't usually be on our graph. So far it looks like this. Then this graph, unlike a parabola which is symmetrical across vertical lines, this graph has symmetry over the origin, which means it looks the same right side up as it does upside down. So we also have to graph the opposite points. So left 1, down 1, left 2, down 8, and left 3, down 27. And again, that one's not very often going to be on our graph. So this is what this this is what this family looks like. It's a cubic. Its nickname that we might call it sometimes is the squiggle. Spell things correctly, Mrs. Black. The squiggle. Okay, and it does that because it goes up and then it kind of squiggles as it crosses the x-axis. The domain of all cubics, like a parabola, is all real numbers because I can put any x value in there. And the range, unlike a parabola, is all real numbers as well because the bottom is an arrow, meaning it goes on forever, and the top is an arrow, meaning it goes on forever, so you can have any real number in here for your y value. So that is the basic, that is the parent function of your cubic family, just x to the third. Then down here, we're going to talk about transformations. Remember, if you have something added after your x to the third, that will shift your graph up. If it's subtracted, it will shift it down. Inside the parentheses does the opposite of what you expect, so something added will shift your graph left, something subtracted will shift it right. A negative in with the x will reflect it over the y-axis, so all of your overs will get multiplied by 1. And when we were doing parabolas, this didn't have an effect on our parabola, but for this guy it will switch it, so it will look like this instead of how it normally goes. It normally comes up from the left and then continues up. This it's going the opposite direction. If there's a negative outside, then this will do the same thing actually, because it multiplies your ups by -1. So either one of these two in a cubic would do the same thing, which makes sense because if you take a negative number to the third, it would stay negative, unlike when we were squaring it and it became positive. So both reflections do the same thing. And then we have stretches. Remember, when you have a number out here being multiplied and it's bigger than 1, that will stretch it. It will make your graph longer and taller. You multiply your up values by that stretch, and remember, when this number is between 0 and 1, that is compression. So that will scrunch it. Okay, so that's the basics. Now let's try some. So back here, first example, we are going to identify the transformations on the parent function, list, this shouldn't say vertex, sorry, this should say first point, list the first point that we graph, and describe how to graph it, and then we are going to graph the function. Okay, so first I know Notice that x and to the third are the only things that are not transformations, so this -3 has to be a transformation. If I flip it back on the other side, I can see that this is going to move me right 3, and then I can see that this after -5 is also a transformation. After, with a subtraction, is going to move me down 5. So remember, right, left, and up and down both affect your first point. So my first point that I graph is no longer going to be at 0, 0. Now it's going to be at 3, -5. So we'd go right 3 and down 5 to get that first point. Then to get additional points, we would still use our pattern. So describe how to graph the function. Well, we would go right 1 and up 1 to the third, which is 1. Right 2 and up 2 to the third, which is 8. And my graph isn't big enough to get that 27, so I'm just going to skip it. Then we'd also go left 1 and down 1, left 2 and down 8. So right 1 and up 1, right 2 and up 8, and left 1 and down 1, left 2 and down 8. Be off the graph a little bit. So then you draw in your squiggle. And my domain is all real numbers, as well as my range, all real numbers. That won't ever change. Okay? Off to the next one. Here my transformations, at least one of them is a little bit different. When we have a number in front of the x squared, that is a stretch or a compression. This is a 2, which is larger than 1, so this is a vertical stretch of 2, and then this moves me up 1, so only one of those affects my first point. Hopefully you know that it is just the up and down that affects my first point. So my first point, I didn't move right and left any, so that's x is still going to be at 0. The y I translated up 1, so it's going to go up 1 and be right here at 0, 1. Then describe how to graph. Well, my normal pattern is over 1, up 1, over 2, up 8, but anytime you have a vertical stretch, these up values get multiplied by your stretch. So instead of going over 1, up 1, I'm going to go over 1, up 2. And instead of going over 2, up 8, I'm going to go over 2, up 16. I don't know if that will fit on my graph though. Okay. So right 1 up 2, and right 2 up, yeah, 16 is going to be way off my graph. Down 2, and 16 is going to be way off my graph. So I'm going to just squiggle this in here and make sure not to cross the next x line, because you can only cross when you go through a graphed point. Okay, and then my domain and range, all real numbers, just like normal, or just like all cubics, I mean. There we go, done. The next one, I've given you some transformations, but I want to change this from left to saying right. Sorry, I made quite a few mistakes. Well, not necessarily mistakes, but realizations after I printed this note sheet, but I didn't want to reprint just for three words, so we can change it. We're flexible, right? So what we need to do on this one is write the function that represents each transformation on the parent function next to the third, identify the first point, and describe how to graph the function, then graph it. Okay, so we are being stretched vertically by a factor of 3, so that's one transformation. We're going to the right 4, that's another transformation, and we're going up 5. That's a third transformation. So if I start out with my f of x and I have x, a vertical stretch, remember, goes at the front, and it's a stretch because it's larger than 1. Then to shift, one of those shifts is going to go inside the parentheses and one of them is going to go after it. The right and left goes inside the parentheses, and since it is right, it does, and it's inside the parentheses, it does the opposite of what we think it's going to do. So this is going to be -4, and then up 5 does what it says outside the parentheses, so I add 5. So my first point to graph is going to be opposite of the inside, outside stays the same. So right 4 up 5, and then I go right 1 up 1, right 2 up 8, left 1 down 1, left 2 down 8, and I hope you recognize that I've forgotten to do something. What did I forget to do? I forgot to multiply by my stretch, so all of these get multiplied by 3. So I'm really going to go right 1 and up 3, right 2 and up 18, left 1 down 3, and left 2 down 18. 18? Who's doing this math? That says 8, not 6. 24. Which is really not going to fit on my graph. I'll do my best. Right 1 up 1, 2, 3. Left 1 down 1, 2, 3. And that would only be 15. Yeah, okay. So we'll draw in what we've got here. Remember not to cross the next x without going through a point. And then I hope you remember that your domain and range are all real numbers. Okay, this next one is a little bit different. Instead of being given transformations or an equation, where it's kind of backwards, we're given the graph and we have to use that to determine the transformations and then use them to write the equation. Okay, well first let's see. Our vertex normally it would be at 0, 0. It looks like we've been moved to the left and up. So let's figure out how far. Left, how much? Well, it looks like my curve is right here, so that means this is my first point. So this is where I'm tracking. So how many have I gone to the left? Left 2. And from 0, 0, how many have I gone up? 1, 2, 3, 4. So left 2 and up 4. And then from that point to the next points should go over 1 and up 1. But you'll notice if I go over and up 1, that point is not there. So how far that I go over does it take me to get up to there? It looks like 3. So that would be a vertical stretch of 3. So now we have to write our equation. So f of x equals x to the third, because this is cubic, and I know it's cubic, it's not a parabola, it's not a line, it's a squiggle, so it's cubic. Vertical stretch of 3. Left 2 goes inside, but opposite of what I think it's going to do. Up 4 goes after, and what I think it's going to say. So that's my equation. And then as always, my domain is -infinity to infinity, my domain is all real numbers, and my range is also all real numbers. Lastly but not least, we need to find all the real zeros, zeros of this function. So the first thing we need to do anytime we're finding zeros is look and make sure everything's on one side and we have it equal to 0. In this case it's equal to y, so we need to change that to a 0. And then we just solve for x. So x is being protected inside this parentheses and cubed, so I need to get everything out of the way so I can get rid of that cubic. So add the 64 because the 8 is being multiplied, so you would first undo subtraction before you would undo multiplication. So 64 equals -8 times the quantity x minus 5 to the third. Now I have to undo my multiplication. negative 8 equals the quantity x minus 5 to the third. Okay, now in the past we have taken, when we've had something squared, we've taken the square root. Well, in this case I have something cubed, so I don't know if you remember this, but you can take the cube root. And let me show you where that button is on your graphing calculator. So if you have your graphing calculator, grab it, turn it on. Find the math button. It's just below the green alpha button. Press it, and if you look, you'll see one that looks like it would take the cube root, number 4. So press number 4, and then we'll type in negative 8 to see what its cube root is. Its cube root is negative 2. So we can rewrite this as negative 2 equals, now the cube root and the cubic will cancel, so this side will just say x minus 5. And so now I only have to undo the subtraction of my 5 to find out that x equals negative 2 plus 5 is 3, so that is my 0. X equals 3. And if you were typing in that into Math Excel, remember normally it usually says the x equals already, you just have to type in 3. Good luck graphing cubics.